Okay, so now we're going to come back to class on Wednesday, and what we will be doing is the lab. So let's look at this lab procedure and let's go through it a bit together, so when it's time for you to do it, you have something to remind you if you forget. What we're first going to do is we're going to prepare 3 styrofoam cups for my solution. I'm going to label each of these cups 0.1 molar, 0.4 molar, and 0.7 molar. So right here, I have 3 different cups. I have them labeled 0.7 molar, 0.4 molar, and 0.1 molar. So you'll have 3 cups because there are 3 different solutions you are going to be making. So far, so good. Carefully use a graduated cylinder to measure out 100 milliliters of water for each of the 3 cups. Pour the water into the cup. So what I'm going to do is I'm going to take this, being as precise as I possibly can. I probably wouldn't pour it from this pitcher. So what I'm going to do rather than that is I'm going to grab a beaker. And in the beaker, I will pour water first because it'll be more accurate, more precise. You also can take the beaker back to your table. So from here, I'm going to take this beaker and I'm going to carefully pour 100 milliliters in here. Place it on a flat surface and let her rip. Went over. Perfect. So right here I have 100 milliliters and I'm going to place it in each of my respective cups. We'll start with 0.7. And then I'll move on to the 0.4. Ran out of water, so I'll use this. Alright, I think I got it that time. Any waste that you have during this lab should go into these awesome yellow buckets that we have from Home Depot. When we have our full class, then we'll be able to use the sink. And I will load my 3rd cup with that water, that liquid. That water will end up being my universal solvent. Now, using a balance, place a piece of wax paper on the balance. So here I have a piece of wax paper. I have wax paper here. Now the wax paper might move in the wind, and I want to show you how to do this. So I'm going to put this on the other projector so I can go over there and I can weigh this for you. But what you're going to do is you're going to put the wax paper on the balance and press tear. That will zero out the balance. So let me place this here so you can see it. I will turn it on. It reads 0.0. Notice we only have the tenths place. We are not going to be able to measure to that hundredths place. Now when I put this on here, this is going to have some mass. Put it there. And if you notice it says 0.3, 0.5. We don't want that mass there. We are going to press tear. That zeroes it out and sets it up so it looks like the paper isn't there. So the paper doesn't count, and we don't want it to count. Now what we're doing is we are going to make the 0.1 molar solution. Now in your calculations, we said, in your calculations, we came up with, we were going to use 1.80 grams for every 0.1 liters. That 0.1 liter would be 100 milliliters. So we are going to measure out 1.8 grams for our 0.1 molar solution. Be as careful as you can. I'm going to take this is Kool-Aid. Go slow, the balances are slow. Here I have 1.8. Wow, went out. If you need new batteries, you may need to know that did go to 1.8 before it went out. Now, the reason we use the wax paper is because it's hard to pick up the whole balance and pour, but it's easy to pick up the wax paper, to keep the Kool-Aid on it, and to walk over to your area. This was the solution for our 0.1 molar. So I'm going to pour this in there. I will take the glass stir rod and I will stir that up until it is properly dissolved in the solution. Now, we did the calculation for the second one, so what the heck? Let's do that second one. I'm going to take this, I'm going to turn this back on. Hopefully that wasn't the battery. If the batteries are dead, guess what? I have fresh batteries. So we are going to do this second calculation. So here it is. Our second calculation told us, remember, we came up with 7.21. Now on this balance, there's one decimal place. So 7.2 is as good as we are going to get. So we'll put the wax paper here. Hit there, so it zeroes out. And now we're looking for 7. Oops, a little windy in here. Now on this one, I know approximately what 1.8 looks like. So 7 is going to look a lot bigger. Okay, so now I'm at 5.2, 5.7. 6.4. Now I'm getting close. I'm going to slow down. I got a little too much there. So what I can do is I can take a small amount off. Wow, I don't know how that went up. So now this extra, I can't put it back in the original container. So what I'm going to do is I'm going to set this aside and I'm going to dispose of it properly later into one of those containers. Now here, what? Should have saved that bit. There we go. We're at 7.2 perfectly. We can turn it off and take our 7.2 grams of Kool-Aid for our 0.4 molar solution. You'll find the proper cup. 0.7 here, that's not what I want. 0.4, check. Now I'll go ahead and I'll pour this in here. And this is a significant more amount of Kool-Aid. Now I will stir this second mixture until it's properly dissolved. Stir them until the Kool-Aid's been dissolved completely. When you're done with that, you're going to observe and taste the solutions. You can have one person that tastes, but you each can taste too. I want you to record how the solution looks, how it smells, and how it tastes compared to the other solutions. Eventually, you're going to answer your post-lab questions. Cleanup, we're going to have a lot of Kool-Aid. We're going to have a lot of sugar. I don't want a lot of ants, so we got to clean up good. We always clean up good. I have faith that you're going to be able to clean the tables, clean up any spills that you have made, dump any remainers in those buckets, and do a great job on this lab. If you have more questions than were answered on this video, you may need to ask Mr. Pacheco. There are probably a few of you that will. Have a great one. Do a good job. Be smart.